Hi, it's CNT125. We're working on Chapter 11 on network performance and recovery. So we're going to jump right in. First topic is just kind of an introduction on collecting network data. The concept of network management is really about assessing, monitoring, and maintenance of all aspects of a network. So once you have designed it, once you have built it, once you have configured it, hooked it up, make it work, if you will, now you change gears to manage. How do I manage this network day to day, week to week, month to month? So it's going to include a variety of things, and they kind of give you a bullet list here of those items. Controlling user access to network resources, and that again is existing users and users coming into the company, users leaving the company, maintaining all of that, server accounts and logons and permissions and all those kind of things. Monitoring performance baselines, continue to kind of take in a little measurement on the network on what's normal, so you have that to compare to when things change. Maybe at the end of the month when projects are due, maybe on a high volume sales day, maybe on the day of a big sale of a company, extra traffic coming in. Okay, maybe at the end of the week on Friday or first thing Monday morning, trying to get a feel for what's normal, so you know anything out of the ordinary, whether it is really out of the ordinary or whether you need to start planning for that as the new norm. Checking for any faults that you have, whether it be switches, routers, computers, printers, access points, IP phones, what faults that you have that you need to address and repair. Setting up quality of service. Again, do you have to worry about making sure that there's bandwidth for IP phone traffic and video conferencing traffic, and limiting other traffic through the network, or what? Again, depending on the facility, this might vary. This might change on what you're doing. Maintaining records of your operating systems, configurations on things like switches, routers, operating systems, patches, updates, that sort of thing. Maintaining records of all this stuff. As we do our network management lab, one of the things we're going to do is we're going to use a TFTP server to gather our network configurations from our routers and devices. So maintaining copies of these things so you can use them in the event of emergency. Determining best time of day for updating, whether it be hardware or pieces of equipment or software or whatever. Maybe it's a certain day of the week, maybe it's a certain time of the day, maybe it's actually Sunday morning. You go in and do these updates before people show up Monday morning, kind of thing. Okay, so determining when those kind of things can take place. Managing a network, the scope is going to change depending on the network size and importance. Example, if you're maintaining a network at a school or a school district, if you will, it's important things are functional and working, but if something breaks Saturday morning, that's relatively low need to fix in many cases. However, if you're working at a hospital, if it breaks Saturday morning, that's still regular operating, I should say operating hours, but that's regular hours of operation for a hospital. It needs to be repaired. So it could change depending on the facility and the size of. There's a bunch of different management disciplines on when things get done and how they get done, but they all basically share the same goal. We need to enhance the performance and efficiency of the network, continue to be maintaining the network and tweaking it for good performance, and try to prevent any downtime or loss to the facility, whether it be a company or a hospital or a school, whatever. So you're really trying to do the prediction of the problems before they actually occur. Try to be preemptive on updating things or repairing things or replacing things before they become a problem. So, some of our tools that we're going to start using. The first category of the tools they talk about is monitoring tools. Network monitor, interface monitor. Network monitor is a tool that's going to continually monitor network traffic. Things like a program like Spiceworks would be doing this. It's actually monitoring the traffic flow going through, looking for any errors, dropped packets, that kind of thing that I'd need to know about. Meanwhile, an interface monitor is a tool that's going to monitor traffic in and out of a specific interface of a device, something like a Wireshark. Here you might be looking at certain protocols moving in and out of a port. So the difference on these is your network monitor is really looking at more than just a single device. You can actually look at a segment or a chunk of the network. Meanwhile, your interface monitor is really only on that device or that particular interface. The book actually shows you some examples in the map, but here's an example of a network monitor, something like a Spiceworks, an actual software package is going to be monitoring traffic flow and bandwidth utilization statistics, that sort of thing. And that would be in here, you're putting monitoring software to catch all the traffic coming and going. Meanwhile, something like your Wireshark that we're used to using, if you really think about it, that's traffic flow coming in and out of a specific device, a specific interface on a device. That would be on something like this. You're connected to a switch and looking at what protocols are coming in and out of this segment of a network, this chunk, this little teeny port, this little piece of the network. They also mentioned wireless monitoring. So if I have an access point having a wireless node connected to it, I might be running software to assess the protocols and things that are operating on the wireless network. They mention at this point, though, that I need to be thinking about with my program that I'm using, I want to make sure it's in promiscuous mode. Promiscuous modes make sure that you're actually receiving all of the packets and opening them, if you will. So if I look at my Wireshark, I'll pull my Wireshark up in here. Here's my Wireshark. It's set on the screen where I would actually start launching and capturing data. Here's my Wi-Fi interface. Well, before I do that, if I go to where my capture options are, where I would pick my interfaces, here's my Wi-Fi interface, you notice I have enabled promiscuous mode, meaning it's going to, any of the packets are going by, it's going to grab them, copy them in, and open them, even if it's not for me. That's something you would need to make sure is enabled on a program like Wireshark here, so that you actually do see all of the packets and frames of data moving by. Something that can help with all of this is port mirroring. So if I do want to see traffic moving through a specific switch or a specific device, I could mirror traffic going to that port and copy it to another port on the switch. So I would, actually before I do that, so if I really want to know what's moving in and out of a particular entity, maybe it's a server, I might set a device here to record that, whether it be monitoring software or something like Wireshark, and I tell the switch, hey, anything going into this port, in or out of this port to a server, please copy to this other switch port over here so that we can see it. Otherwise I would not. So what I do is on my switch is I actually configure it to say, hey, anything going in and out of this port here, please copy it to this port here. That's the destination port. And I actually do have an example. I think I have, hold on one second here. What I would use to do that, I could actually even use that in conjunction with a inline monitor. So if I have traffic moving in and out of here, I could copy that. Actually, let me back up here. Hold on, here we go. So here is my device here. I'm capturing traffic. I want to capture traffic and see it on this device. So traffic moving through the switch, I say, hey, please copy it and send it over to here. I might use that also in conjunction with something like this guy here, my inline monitoring. So what I could do is traffic moving in and out of the switch, I would copy to the switch port, etc. So it might look like so. Let me go to this guy right here. Okay, here's my packet tracer up. I actually have this open for two different examples of things I'm going to show you. So we're just going to focus on the left half right now. Here's my switch. I have a couple workstations plugged in. This guy is 192.168.10.1. This guy's 10.2 and port 2. This guy's 10.3 and port 3. And then I also have this guy over here, this workstation plugged into port 20. That's port 20 over here. So if I look at my switch over here, I'm going to pull up the switch configuration and say, hey, let me see the switch. And I'm going to do a show run on this guy. I'll see that I do have, there's no VLANs or anything on here. I do have some things down here I'm going to show you later, but if I keep going, down at the very bottom, I have, hey, monitor session source interface faster than 0.1. Anything on 0.1, any traffic moving in at 0.1, please copy to monitor session destination interface fast Ethernet 0/20, please copy to switch port 20. So if I did want to monitor traffic coming in and out of this thing, maybe it is a server, what I could do is I could tell the switch, hey, anything moving in and out of this port, please copy to this thing over here. So I might be running network monitor software here, or I might be running a protocol analyzer or something over here. So what I have done is I've taken and configured the switch that anything coming in and out of this port, please copy to this port over here, and I've installed a network sniffer. It's like a network monitor. It's more like a Wireshark. And it's set up right now to only show me ICMP packets. It's only going to show me ICMP packets moving in and out. So I've kind of set this up to be almost like a Wireshark. So what I'm going to do over here is I have workstation 3. I'm going to issue a ping from 3 to workstation 2. So if I take a look and do ping.2, okay, so I'm pinging workstation 2. I'm getting successfuls. Let me go back to my sniffer here. Boop, let's clear him off. There we go. I see, even though that thing is pinging away back there, this guy's pinging away back here to workstation 2, my sniffer is showing no traffic. Because really, when you think about it, 3 is pinging 2. That's a direct thing between those two. This guy over here is not seeing any of that. So let me come back here. This guy, I'll stop him. But now let's ping computer 1. So I'm going to pull up .1. And I'm going to start pinging him. And what should happen is when I go to ping from here over to 1, the switch should also copy that and send it to my network monitor over here, my network sniffer. So I'm going to start. Let me see if I can get both of these windows up here. Okay, get my sniffer up here. There we go. All right. So there's my sniffer sitting there just kind of hanging out, not really doing anything. So I'm going to issue my ping. And when I do, my sniffer over on port 20 is getting copies of that. Because I told the switch, please, port mirror, please copy those and send them to switch port 20. I'll stop my ping. I don't need to keep that running. And if I do look at these, if I look at one of these, this actually shows my header of things over here. The destination address, there's the destination MAC address, there's the source MAC address. If I keep going and look at the header, here is my... Keep going. Source address 10.3 going to 10.1. And my workstation over here was, let me close this guy. I was over here on port 20. So that's proof. 3 was pinging 1, but I was capturing over here on port 20, showing you that port mirroring does actually indeed work. And that can be handy coming back here. That can be handy when I'm trying to monitor specific parts of my network. I can tell my switch, hey, please send me a copy of that. Please show me that information, please. Very handy. Network monitoring tools can perform all kinds of functions. Set the NIC to run in promiscuous mode. We showed you that. Continue to monitor network traffic. Yep. Capture network traffic. Transmit on a segment. Yep. Capture frames. Yep. Send it to a node. Reproduce network conditions by transmitting a select amount of type of data. Yes, you can. And generate statistics about network activity. Yes, absolutely. That's what your network monitoring software and programs can do. Sometimes it can also do these functions. Help discover network nodes. Yep. Help with baselining, which we're going to talk about. Utilization statistics. Store data traffic and generate reports. Trigger alarms. Identify anomalies. Yes. Certain programs can actually do that. Actually help you with building that information to know if there's particular problems going on and maybe even predict them. So here's your network monitor. Again, these were things like that, Spiceworks and so forth. Meanwhile, your packet analysis, like your protocol analyzer, allow you to dig into specifics on that particular protocol. Monitoring tools can help you identify some of these problems. Runts, giants, jabber, ghosts. And these are all going to let you know different problems might be occurring in the network. Give you some kind of a clue as to what's going on. Recognize those terms in case you run across them in your network monitoring program. And all these do have the idea of trying to give you heads up if there's problems in the network, that you might be able to be proactive on that, and even giving you some text messages to alert you that there's a problem or a fault going on. Logs are also generated in all your servers and devices. These can be handy to help with trying to identify problems. You can have event logs in something like a Windows system, or a sys log in something like a Linux or Unix system. These can show you whether there's particular issues with wrong logins, wrong passwords, IP confliction problems, etc. Very useful to try to track down particular problems. Linux or Unix or Linux systems are going to use the syslog function, but again, show you if there's particular issues happening with nodes in a network. All right. We're going to come back with SNMP in the next section.